We are Streetmagic, a project sponsored by Drive Safety. The members of our team are Darren Ashdown, Kelly Harper, Andrew Sumption, and Andy Chadwick. Darren was in charge of the terrain generator and the interactive map preview. Kelly was in charge of the street generator, the street editor, and the overall system orchestration. Andrew was in charge of the building generator, the AI texture generation, and the OpenStreetMap integration, and Andy was in charge of the asset generator and the asset editor. So about our sponsor, Drive Safety. Drive Safety is a company that manufactures driving simulators for the clinical environment. Their end users are often people who are learning or relearning how to drive. They manufacture a variety of driving simulators, all running on their older driving simulation platform. Currently, they're in the process of overhauling this and completely remaking a new simulator in the game engine Unity. And this is where we come in. We are helping with one small part of their port to Unity. Our part is a tool to dynamically generate 3D worlds based on real-world map data. So without further ado, we'll get into the demo. Alright, so here we are in an empty Unity project with Streetmagic installed. To get started, we go ahead to the Streetmagic tab, click here. We can see a preview of the map. Right now we're up at Salt Lake City. Say for example we wanted to do around the university area, like the Warnick Engineering Building. I could type that in right here. Click Find Address, and it will center on the place I typed in. I can go ahead and change the size of the area that we're generating. I'll go with about that big, and then we just go ahead and click Generate. Alright, now that that generation is complete, we can go ahead and take a look at a few of the features. Alright, the first feature we're going to take a look at is the street generator. So as you can see, we've got some streets filled in here with lane lines, smooth intersections, and curbs, and overall looks pretty realistic. And these streets are in fact based on real-life street data, as you can see here. Streets can come in a variety of types with a variety of lane configurations, and you can see some examples here, and there are also residential streets with no lane markings. One critical feature of the street generator is the ability to edit streets that have been generated. So when we click on a street, we can see the individual nodes that make it up. We can click on them, drag them around. We can create new nodes between the individual nodes. We can create new nodes outside of the nodes to create new streets. And we can also join multiple nodes together, like so. We can also customize the number of lanes each street has. For example, I'll click on this street right here, select a node, and then on the right side of the street I'll add another lane, and then click this button to add that lane to all prior nodes, and all nodes in the other direction as well. So now we have another extra lane on the side there. We can go ahead and refresh the terrain height to sync our changes with the terrain. Alright, the next feature we'll take a look at is the asset generation. So as part of that, we have stop signs that are generated at street intersections. Similarly, there are traffic lights, speed limit signs, and trees populated throughout the world. Another useful feature of these assets is that they're customizable. So for example, with these street lights, we can customize which lights are enabled and how many of them are enabled, like so. And we can also change the name of the street. The speed limit signs can also be adjusted with the asset editing tool, and any value can be input for their new speed. The next feature to highlight is the building generator. So these 3D buildings come from the Google Maps API called 3D Tiles, and we take the 3D data from there and cut it out using building outlines that are sourced from OpenStreetMap. Here you can see a few examples of buildings that are generated from such a method. Another useful feature of these buildings is the ability to automatically regenerate their textures using an AI model called Stable Diffusion. This is useful because often the models that we get from Google 3D Tiles do not look super great from street level. For example, here's the Merrill Engineering building, and because of the way it was scanned in Google's dataset, it looks quite warped. So we'll go ahead and use the tool to try and regenerate the textures. So there you can see we have something that looks a lot more clean. There is a little bit of interesting stuff going on the side because these AI tools aren't perfect, but I think we can say that the result here is definitely much better than before. Finally, our last main feature is the terrain generator. As you can see here, we've got elevation levels sourced from the real world. Here we're seeing the start of the mountain behind the U. The way we get this data is we source it from an API called Open Topography, and then we take that data and interpolate it and insert it in as a native Unity terrain object. As you may have noticed, the terrain seems to reflect the colors that would match real life. This is especially obvious looking out over a city landscape. The way we do this is we take a satellite image of the region and then classify each pixel into one of a few categories of terrain that it's closest to, and then use all of those to blend together a unique terrain texture that matches real life. Additionally, we have two stages of terrain, the finer detailed and the less detailed that's larger. In some cases, when there are faraway mountains or other such features, this faraway, low-detailed version of the terrain is useful. And that is the main overview of our project. Obviously, the results here are not quite perfect, but the motivation for this project is to get something, a good baseline, that is the majority of the work that an actual human will go through and edit and refine later to suit their needs. To wrap things up, I'll go over the technologies that our project used. So our project is a bit different from most capstone projects in that it's not a web app and is mostly built from scratch. The main technology that we used in our project is the Unity game engine, which it's built upon. Additionally, we use several external data sources to implement our project. Google Maps provides 3D imagery that contributes to the buildings, and OpenStreetMap also provides building outlines which are used to cut out that imagery. OpenStreetMap is also used by the street and asset generator. The streets come directly from OpenStreetMap, and a few of the assets do as well. Some of the assets are based on street data. Both Mapbox and Open Topography contribute to the terrain generator. Mapbox is used for satellite imagery, and Open Topography is used for the actual elevation data. The one final tool that we integrated was Stable Diffusion, which we used in an image-to-image configuration for the building texture generation. Thank you for watching our presentation and learning about Streetmagic.